The serpent's glide, a symphony of motion and skin. Snakes, creatures of mesmerizing beauty and stealth, navigate their world with an elegance unmatched in the animal kingdom. Their limbless bodies, far from being a hindrance, allow them to move with remarkable agility through diverse terrains, from dense undergrowth to sun-baked deserts. This fluid, almost effortless movement is a testament to the unique design of their skin. More than just a covering, snake skin is a crucial element of their locomotion, providing the grip, flexibility, and protection essential for their survival. Snakes employ various methods of movement, each relying heavily on the properties of their skin. The most common serpentine locomotion involves lateral undulations of the body, pushing against the ground to propel the snake forward. This requires a surface with sufficient friction, a role perfectly fulfilled by the specialized scales of their skin. These scales, overlapping like roof tiles, create a textured surface that grips the ground, preventing slippage and facilitating efficient movement. But the importance of snakeskin goes beyond just movement. It serves as a protective barrier against the environment, shielding the snake from abrasion, dehydration, and even predators. The durability of this skin is truly remarkable, allowing snakes to thrive in some of the harshest environments on Earth. From the scorching sands of the Sahara to the humid depths of the Amazon rainforest, snakeskin has evolved to withstand an impressive array of challenges. Understanding the secrets behind this remarkable material has captivated scientists for decades. By unraveling the intricate structure and properties of snakeskin, we gain not only a deeper appreciation for these fascinating creatures, but also valuable insights that could inspire new technologies and materials. A closer look. Unveiling the layers of protection. The remarkable durability of snakeskin lies in its ingenious structure. Far from being a simple, uniform covering, it is a complex, multi-layered marvel of natural engineering. Each layer plays a specific role, contributing to the overall strength, flexibility, and resilience of this extraordinary material. The outermost layer, the stratum corneum, is the snake's first line of defense against the outside world. Composed of tightly packed, keratinized cells, this layer is remarkably resistant to abrasion, protecting the snake from scratches and scrapes as it slithers over rough surfaces. The keratin, the same protein found in our hair and nails, provides exceptional strength and toughness. Beneath the stratum corneum lies the epidermis, a thinner layer responsible for generating new skin cells. This layer ensures that the snake's skin is constantly renewed, shedding old, worn-out cells and replacing them with fresh ones. This continuous regeneration process is essential for maintaining the integrity and functionality of the skin, allowing it to withstand the wear and tear of the snake's active lifestyle. Further down lies the dermis, a thicker layer containing blood vessels, nerves, and connective tissues. This layer provides structural support and nourishment to the skin, while also housing specialized cells that contribute to the snake's unique sensory abilities. The interplay of these different layers, each with its specific properties and functions, creates a material that is both incredibly strong and surprisingly flexible. This unique combination of strength and flexibility is what allows snakes to move with such agility and grace. The tough outer layer provides the necessary protection and grip, while the softer inner layers allow the skin to stretch and bend, conforming to the snake's movements without tearing or breaking. Impact absorption. Lessons from nature's engineer. The durability of snakeskin extends beyond its resistance to abrasion and wear. It also possesses remarkable impact-absorbing properties, protecting the snake from potential injuries as it navigates its environment. This ability to withstand impacts is crucial for snakes, particularly those living in rocky terrains or those that rely on striking prey. Research by scientists like Marie-Christine Klein has shed light on the mechanisms behind this impressive impact resistance. Klein's work has revealed that the unique arrangement of scales and the underlying collagen fibers in snakeskin play a crucial role in distributing impact forces. When an impact occurs, the overlapping scales act like a series of miniature shields, deflecting the force away from the snake's body. This initial deflection is only the first line of defense. The underlying collagen fibers, arranged in a complex, interwoven network, further dissipate the remaining force, preventing it from concentrating at a single point and causing injury. This sophisticated impact-absorbing system is a testament to the power of natural selection. Over millions of years, snakes have evolved to thrive in diverse environments, and their skin has adapted accordingly, developing specialized features that enhance their survival. The ability to withstand impacts is just one example of the many remarkable adaptations found in snakeskin. Understanding the principles behind this natural impact-absorbing system has significant implications for various fields, from material science to bioengineering. By mimicking the structure and properties of snakeskin, researchers aim to develop new materials with enhanced impact resistance, potentially leading to safer helmets, body armor, and other protective gear.